Hi everybody, so welcome to another module on Kubernetes. So here what we are going to do, we are going to set up the Kubernetes cluster on the AWS EC2, right? So let us quickly dive into the console and let us quickly set up our Kubernetes cluster. So first we'll start with the control plane, but before that we need to log in. So I'll log in using the root user email. So let me put in my email ID. Okay, perfect. Let me go into the login password. Okay. The touch part is also done. I think we have logged in. Perfect. So now what we are going to do, so we are going to go to our EC2 instances. So let me go to the EC2 instance and let me launch an instance quick. So launch instance, skip without a walkthrough. Let me name the instance name as control plane because that is what this particular node is going to do. And here we are going to choose Amazon Linux, and then coming down instance type, we were always using free tier eligible, but here for control plane all does all the muscular work. It is the brain, so we are going to use T2 medium over here, and you can use it, no problem, but beware of the fact that when the EC2 instance is not in use, when you are not using your cluster, then you can stop it, because else you will be charged with unnecessary billing, right? Now here I have to choose a key over here, so I have already created a Kubernetes key. You can just create a new key pair and then you can log in, and let us keep everything default for now, and let us launch the instance first. So once the EC2 instance gets launched, let me open the terminal as well in the meanwhile. Okay, terminal is open. Now let me zoom it a little. Okay, let me route it to user, then Ashish, then there is this desktop. Perfect. ls. Okay, let us check whether our EC2 instance has been successfully launched. So it is running. Perfect. Now we'll copy this public IP, and what we are going to do, we are going to SSH into our system. SSH hyphen I followed by our PEM file, and then by our user, which is EC2 user in this case, followed by our IP. Yes, and we have logged in. So currently, let me check. We don't have any Kubernetes thing installed over there. kubectl get pods. No, nothing, right? Nothing as of now. So what we'll do, we'll quickly configure the security group. So basically you need to understand one more thing. What you need to understand for control plane, the instance type what we generally choose is T2 medium, and the OS should be Amazon Linux 2. Why? Because it offers a large storage, and even the vCPUs and all configurations are pretty much higher as compared to the regular or the free one that we are using, right? So now let us go to the security groups, and let us change this a little bit. Let us add some rules over here. So here we'll be editing inbound rules. So here this particular SSH port 22 is used generally for our login, so that we can log in, or we can SSH into our EC2 instance. So that is what the use of this particular port 22 that we have opened. Now we will add the rule. So let us add the rule over here and let it be custom TCP, and then we are going to add a port called as 6443. So 6443 is the port for the Kube API server. So we are going to put it not my IP. Let me put the IP over here, that is 172.31.0.0/16. So this is where it should be. So this is what we are making configuration, that via port 6443 the Kube API server could communicate with the registered worker node. And then we'll also add a rule, one more rule, wherein we'll be ensuring a kubelet port. So kubelet port is 10250, and Again, it is also going to be the same over here. So this is the CIDR range that we are going to use over here as well. So this is also done, and now we are going to use one more rule, that is for the node port. So here, for example, if we want to expose any application via node port, so we'll be using these all ports. So let me whitelist the port range, that is 30,000 to, needs to be in the range of, okay, 32767. So you have to remember this particular range. Why? And we have to allow traffic from anywhere. So these are the ranges that you should be knowing, and here I'll be writing. So this particular port is used by kubelet. This is used for kube API server. Kube API server. Okay, everything is done. We'll save the rules now, right? Okay, now we'll do the control plane setup first. So let me quickly come down here, and I have also got a list of steps that is already there. So meanwhile, I'll also explain you what we are doing. So here we are disabling swap. So in the Linux system, we also know that when a system is rebooted, or when a little Linux system is up, so it creates three space, that is root, boot, and swap. So here we are disabling the swap. Why? Because Kubernetes scheduler requires accurate memory counting, and swap means extra memory on the disk. So like if found free, Kubernetes scheduler will schedule more pods into it, which we really do not want. We want the pods to be scheduled on the main memory rather than the swap memory. So this is what we are doing. So the first command says that sudo swap off, so we have disabled it, and then we are also going to disable it inside the file which is under etc and fstab. So this is also done. So what this basically means is like if you see -i says that edit the file, and this swipe is the this swap says that find this particular line inside the file and comment it, which file, etc fstab, right? So this is done. Now we are going to enable kernel modules. So let me go to the kernel modules, and do not worry, I'll be sharing all these modules to you guys. So first we'll be enabling the kernel modules over here. So this is what we need to do, and we need to enter. Okay, so what this has done, so this step ensures that Linux kernel loads all the required modules that Kubernetes and containers networking depend upon, right? Configuration files are created at what location? At location etc modules load kubernetes.conf, and creates two modules, name overlay and net filter, right? So overlay is basically your container file system, and net filter allows network rules for the containers. And what is the next command that we have to do? Now we have to use sudo mod probe overlay. So mod probe loads the module right now without rebooting. So that's the only use of that mod probe. So this module is also loaded without rebooting, and this module is also loaded without rebooting. Okay, these two are done. Okay, what's the next step? Next step is we have to configure networking, right? So we have to run this command first. So let us run this command, and let's see. Okay, this is done. So what is happening here? Now we are preparing the Linux kernel to support containers and Kubernetes networking. So a kernel module is a feature that can dynamically load into the Linux kernel. That means enables packet forwarding, pod networking, and everything. So this basically says that please allow pod traffic to be routed properly, and allow Kubernetes IP table rules to apply to all pod network packets. So that is what it says. And here we have to again run this command, that is systl. Okay, these all file and configurations are done. Now we'll install the container runtime. Okay, so what is the next step? So as I said that we are preparing the Linux kernel to support containers and Kubernetes networking. Okay, now we will be installing the container runtime, that is step 4. So sudo yum install -y containerd. So we'll do this, and let's see, containerd is installed. So this basically installs containerd, which is a container runtime used by Kubernetes to run containers instead of Docker. So earlier we used to install Docker, but now there is a more generic container runtime, so that is containerd. So this command does install the containerd over here. So you can see the installation. Okay, now if you see the second command, it says that sudo make directory and inside the parent directory create this containerd file, containerd directory. So generally what happens, this particular directory often doesn't exist by default on Amazon Linux too, so we create it manually. So this is done. Perfect. Now what we are doing, we are running this containerd config default and we are also creating a file called as config.toml. So here we are generating a default configuration and saving it to this particular location, that is config.toml. Okay, this particular configuration is done. Now there is one critical fix that we have to do. So here we have to open this particular file, that is config.toml, that we have created, and we have to disable systemd C group, right? So let us open the file location. I think I have the file location over here, sudo vi. So we'll open this. Okay, now we have to find where do we see systemd. From false we have to change this to true. Okay, okay. Do you see this over here? Systemd false it is set, so we have to make it true over here. So we have to go it over here and then we have to change it. Okay, true. Perfect. Escape :wq and save. Okay, we have came out. Now we have to restart the containerd and we have to re-enable it. So what is the command for restart? We have changed it to true. Now we have to do sudo system restart. So we have to restart it over here, restart containerd. Perfect. Now we have to re-enable. So Kubernetes requires systemd C group driver for driver alignment. So that is what we have done. Okay. So let us talk a little like why Kubernetes requires system C group driver alignment. Because they manage container resources, right? What resources like CPU, memory through the same C group hierarchy. So if they use different drivers, that means there will be a conflict. So kubelet uses systemd and containerd uses C groups, right? So they cannot coordinate properly. So hence we are making these changes. Now we have to add a Kubernetes repo. So what is the Kubernetes repo that we have to add? So this is the command that will help us add the Kubernetes repo. Now we'll understand what this command does. So we'll just add a Kubernetes repo over here. Okay, this is done. So what basically we are doing here, so if you look at the command properly, so here what it is saying, so this block creates a file that tells your system where to download the Kubernetes packages from, right? So here if you see that the first step is okay, Kubernetes repo, right? So here what we are doing, we are creating Kubernetes repo. This tells yum where to find the Kubernetes package. Then there is a base URL. Base URL says that official Kubernetes RPM repository location. And enabled equals to 1, that means activate the repo. GPG check equals to 1, that means check the package authenticity, whether it is authentic or not, because we don't want the cluster to be compromised. And then there is this GPG key, which is that to verify signed Kubernetes package, right? So that is what we have done. And now I think this is what we have done. Okay, we have done that. Now we will install Kubernetes tools. So we will install Kubernetes tools. So first we are going to install this kubelet, kubeadm and kubectl. So let us install them. Okay, so all these are getting installed. So basically kubeadm is a utility of Kubernetes that is used for cluster bootstrapping. So it is used to create and manage cluster. So basically what all role does kubeadm will do? So kubeadm will initialize the control plane, then set up the certificates and encryption, then configure API server, scheduler, control manager, also creates to join tokens for worker nodes. For example, we will also see that when we create a worker token, we have to create a worker node, we have to create a token at master node and we have to run it. So that's how that worker node will join. And then it also helps with upgrades and resets. Moving on to kubelet, so we have also, if you see the command, we have kubeadm is what we have understood, it is used for bootstrapping the cluster. Now there is kubelet. So kubelet is one of the most important component on every node. Why? Because it talks to the API server, it also manages the pods and containers on that node, communicates with containerd, ensures that pod are running as expected, watches pod specifications, maybe creates, destroys containers accordingly. So that's why it is very important to understand kubelet, and that's what we have installed. And third is kubectl. So we all know that every command, every operation or every object creation, whatever operation we have to perform on that cluster, we use this kubectl utility. So this is basically a Kubernetes CLI. So Kubernetes CLI is primary command line tool used to interact with the cluster, right? So I think we have installed this. Now we will enable kubelet. So we have to enable kubelet right away. So let us enable the kubelet. Okay, so this is done. Now what we'll create, now we'll initialize the control plane. So what is the next step? We have to initialize the control plane. So here what we are doing, we have to run this command kubeadm initialized pod network CIDR, and then is this address space that we have shared. So Kubernetes begins building the entire control plane on your master node. Now this steps also involves like certificates, networking, static pods, kubelet, bootstrap, etc. So this is what is being done. And kubeadm config pull images. So let's see. Sync version is newer, failing back to stabilize. Okay, let's see what it is doing. So these all are the very simple steps. You have to just understand the explanation what I am trying to say behind each and every step. I'll be sharing all the steps, in the comment section, or maybe in the description of the video. You can just watch it from there. And in just next 8 to 10 minutes, you will be able to run your own cluster. So what is the next step now? So I think the last we did was to initialize control plane. Now next what we are going to do, we are going to configure kubectl. So we are going to make a directory. So let us make a directory like this using this command. Okay, this directory is created. Now we have to make this particular configuration file and give the access to the cluster. This is done, and now we have to change the ownership. So here we give the, this is done. So here what we have done, here basically we have given kubectl to access the cluster API. So kubeadm first checks the system to prevent misconfiguration. It checks like, what all checks we do. We check that swap is disabled, then required ports are open, then container D is running, kernel modules are loaded, C group driver is correct, CPU, RAM requirements, everything. So if something is wrong, it stops the initialization and tells us the exact issue, right? So this is done. Now what we are going to do, we are going to install the networking over here. So install network CNI. So we are going to install this Calico, right? So this step installs the CNI, that is container network interface plugin. In this case we are using Calico. So without these steps, your Kubernetes cluster cannot function even if all the control plane components are running. So this is done. Perfect. Now what is CNI? CNI is nothing but container network interface that is responsible for assigning IP address to the pods, enabling pod to pod communication, pod to node communication, services, networking like cluster IP, node port, and all these, right? Okay, so what will happen after this step, after we perform this, what will happen? So once the Calico starts pod CIDR range, that is /16. What range did we use? This one. This range is used. Each pod gets an IP from that range, and routes are programmed in the kernel. Kubelets detects the working network, node status become ready. So that's why so that is what happens over here. And why we use this particular range over here? Because this CIDR matches Calico's default IP pool and prevents IP conflicts, and at the same time allows Calico to allocate pods IP correctly. So if this CIDR is mismatched, then pods won't get their IPs, node will remain not ready. So that's the problem. So we have fixed that over here. Okay, so I think this is done. Now let us check kubectl get nodes. Perfect. So our control plane setup is done. So here do we see this control plane over here, and let us see kubectl get pods, kubectl get namespace. Let us see what all namespace are there. Okay, let us check the kube system, that is the internal. Kubectl get pods -n, n is for namespace, kube system, right? Let's see. Okay, no resource in the kube system. So fine. So basically the motive was like, we have successfully created our control plane, and we have configured it as well. So if I use kubectl get svc or the services, so this is running, right? We have got a cluster IP. Perfect. So we have achieved our first step. That means we have created the the control plane. Now let us create one more EC2 instance and configure it for the master node. So this is the control plane, that has been terminated. Now let me only check instance state. Okay, this is there. Now let us create one more launch an instance. So let this be worker node. Worker node. Okay, worker node is here. Same Linux, and here in this worker node, we are going to use the T2 small, not the free tier again. So let us not let us rule out all the ambiguities that whether it will work or not work. So let us take small, because worker nodes are used to only schedule application or maybe workloads on them. So this is the security group. Let us keep, okay, the key pair. Let me log in using the same Kubernetes and SSH traffic and all, everything perfect. We can use this, select an existing security group. So we have already a security group that is created. Let me check what is the name of the security group over here. So the security group is this. Let me select this, because no need to configure the ports again and again. If this works, it is good. If not, okay, I don't know why this has not taken security group name launch wizard 20. Okay, this could be the reason. If not, no worry, we'll create it again. Launch wizard 20 is there. Perfect. Now we'll just launch the instance. Okay, this has been launched. What is this? This is the dashboard. Let me go to the dashboard. Let me go to the instance running. And okay, worker node is also running. Perfect. This is initializing now. Now let us open this control plane. Okay, perfect. This is the control plane. Let us put the control plane over here. It's got an IP, and now we are just waiting for this to work. Perfect. So this is also running. Now let us log into this. So I'll just quickly copy this, and I'll just use another terminal. Okay. I don't need to find anything. I just need a new terminal. Okay. Let me zoom it a little. Perfect. SSH-I cube. No, it won't work because I have to just change the directory. So it will be user, then it is Ashish, then it is desktop. Perfect. Now SSH-I, same step. You will be used to it. I would just because this is also very important. Why? Because in the interviews and all, if you are asked to perform or do certain operations, then you can just you should have created a Kubernetes cluster on your EC2 instance. It is all absolutely free, I mean almost free, and then you can just showcase it to your interviewer, so it will create another good impact of yours. CT user followed by IP is this. Let me see, 52 is the IP, right? 52 is for the worker node. Perfect. So yes. Okay, perfect. Now what we have to do in the part 3, we have to repeat the step same as 1 to 4. So let us repeat the step as same as 1 to 4. So, and before that, let me check the security configurations of this. So this is security, and this is the inbound rule. So all the rules are in place. Perfect. That is what we have. That is what we wanted. Perfect. So now what we do, we just repeat steps from 1 to 4. So what was step 1? We have to disable the swap. So let us do it. We'll do it quick this time. Okay, this is done. Now we have to also hash it out. This is also done. Okay, step 1 is done. We'll move to step 2. Here we are going to enable kernel module. So here what we are going to do, we are going to again copy the same command, run it. Perfect. So 2 modules are created, overlay and net filter. So this is again what. So this time I'm doing it quickly because we have already understood like what these modules are going to do. We are going to enable kernel modules and what they are going to do, how networking is going to take place. So this is there. Okay, now the step 3 is configure networking. So here we have to use again this command, and we have to configure the networking. Okay, this is done, and we have to, this is CTL. Okay, this all necessary files and all are created. Now step 4 is install containerd, because if containerd won't be installed, who will be spinning up the containers? Okay, so this is installing the containerd now, which is very good. Okay, containerd is done. Now we will make a directory containerd This is also done. Perfect. Now you have to create a file called as config.tuml. Config.tuml is created, and then you have to again change the value from false to true for system DC group. Okay. Okay, this is done. Now let us quickly find where is that system D located. So here it is. Change the value to false. Okay, I think I have to put insert. I have to change it to true. True is done. Escape. Okay, done. So this is also done. What is the next step? So this is done, and then we have to restart containerd and we have to enable it. Okay, this is the restart containerd, and then we have to enable it. Okay, done. So now let us check. We have done from I think step 1 to 4. Now let us see what is the next. So step 1 to 4 same as master. Now add 5. We need to add Kubernetes repo also. So this is also same. So let us. Okay. Okay. So let us. Step number 5 is also what we'll be repeating. So step number 5 is to add the repositories. So let us copy this and then okay, this is done. Perfect. Now what is the next? Now here in step 6 we have to install again these all three utilities. We understood what are they used for: kubelet and kubeadm and kubectl and everything. So let us do this. So this all gets installed, and then we have to enable kubelet right away. So you can read more about these all steps in the documentation as well. Everything is well documented. I have taken all the commands from the documentation itself. I do not want to make this demonstration pretty monotonous while explaining the documentation. So yes, that is it. So now we have enabled it. Now what we do, we initialize the control plane. No, here it is. Okay, so we have enabled it. Now what we do, we will on the master node, we will print we will generate a token. So we will use this, and let's say we are on the master node. So this is our master node, and let me generate a token. So this token is generated. Now here what I have to do, I have to use this particular token and I have to run it on worker, and then it will create a running to C5 running flight pre-flight checks error user is not running as root. Okay, I think do I have to use sudo and then the command? Okay, this is done. What is the next step? Token is generated. What happens now if we see or if we check here at master, we do not do we literally do not do any operations on the worker node. All we have to do is on the master node itself. So kubectl get nodes, right? Perfect. So we have got control plane, we have got master node configured. So and let's see, let us check like if we create a deployment using nginx only with one replica. Let's see what happens now. So deployment is created, kubectl get deployments, kubectl get deployments. So this is done. Now we will scale it to 2 replicas. So let us see how many pods are there. kubectl get pods. So here we have got one pod that is of nginx. Now let us scale it. So we'll just scale the deployment. Okay, so this has been scaled to 2. Now we will quickly run the get pods, and we see the 2 are running. Now let us see kubectl get pods oh wide. Kubectl get pods oh wide. So this will tell like where these pods are currently scheduled. Oh wide. Okay, So nominated node none. So that means it is on the not on the control plane, because if it was on the control plane, we could have seen it over here. So what node is it here? So it is 212. So 212, do you see? So 212 is of the worker node. So these pods are scheduled on the worker node. Now let us expose the service. So let us expose it to the service. Okay, service is exposed. kubectl get services. kubectl get service. Okay, node port service is created. Now you have to take this port and you have to take the IP. Okay, EC2 IP, and then we have to use this, right? Okay, HTTP followed by, let me also put this port over here, and what is the IP? We are going to use the IP. Okay. See, it is working, right? So that is what we have done today. So today we have created a Kubernetes cluster with one master and one worker node right from scratch, which all the steps, only 10 steps needed, and within 10 minutes you can spin your own cluster. And then we have also run the sample command and we have exposed this to the public internet, and then we could access the application. So this is how super simple it is. And if you guys still perplexed, I have already made two videos on Kubernetes. One is like why Kubernetes came into existence, with a beautiful demonstration, so that you will have an understanding that why Kubernetes came into picture. And the second video was about the Kubernetes architecture. So what are the different architectures? That is single node, which plays the role of both control plane and worker. Then there is one master, one worker. So, and the entire terminologies that we use inside the Kubernetes architecture, the control plane component, the worker node components, everything. So I'll be pasting the link of these two videos here at the end of this video. I would highly recommend you to watch this video so that you can follow this particular demonstration way better. And stay tuned for upcoming videos wherein I'll be decoding much more complex concepts of Kubernetes into a very simple fashion, breaking down all the complexities for you to understand in a very easy way. So thank you for watching, and signing off, Ashish Bharti. See you in another video.